The next question is, find the least initial velocity with which a projectile is to be projected so that it clears a wall of 4 meter height located at a distance of 5 meter and strikes the ground at a distance 4 meter beyond the wall. The point of projection is at the same level. So let's draw a visualized figure, this one. Let us consider the same level horizontal ground and consider this as the point of projection as A, and consider another point B as the point of landing. So from here projectile has been projected and it reaches and let u be the initial velocity with which it has been thrown. So here this be the velocity u with which it has been thrown. Okay, this one is initial velocity and the angle made by this be alpha. And they said find the least velocity with which a projectile is to be projected so as to clear a wall of 4 meter height located at a distance of 5 meter. So let us consider this as one wall which is located at a distance of 5 meter from point A. Okay, so let us consider this as one wall. A wall is there and its height is given. So that height is 4 meter. So this is the and strikes the ground at a distance of 4 meter beyond the wall. So after 4 meter it is going to strike the ground at a distance of 5 meter after wall. Okay, so after wall it will be striking the land or the ground at a distance of 4 meter. So this is the available data. So from this I have to determine the initial velocity, the least initial velocity and the angle alpha. So now from the available data I can write the two equations. So one is, in this one, the relation between x and y is given, that is at a distance of 5 meter along x the particle has to clear a distance of 4 meter along vertical. So that is, when the relation between x and y is given, means I can write a equation of trajectory. So equation of trajectory, that is y is equal to x tan alpha minus gx square upon 2u square 1 plus tan square alpha. So this is one of the equation I can write by looking into the figure, and one more I can write is the range is given. It has to travel from here to here. Range is equal to 5 plus 4 is equal to 9 meter. So range is given. Equation of range is equal to r is given by u square sin square 2 alpha upon g. These are the two equations available for us to solve the question. So now see here, if I choose this one, so here y is known to me, that is this one is y, x is known to me as x is 5 meter. Okay, for this particular case at a 5 meter distance 4 meter wall is there. So x is known to me, y is known to me, but alpha is a unknown quantity which I have to find. G is known to us, x is known to us, but u is unknown here, which we have to find. Then next, coming to here, alpha is the quantity which we have to find. So here in this equation there are two unknowns. One is this u and another one is this alpha. So whenever there are two unknowns, I need two equations to solve the numerical. Then next, coming to this one, that is equation of range. So here r is given, yes it is given, but u is not given, alpha is not given, and g is known to us, that is 9.81. So again here also the unknowns are u square and alpha, and in the equation 1 also the unknowns are this u square and alpha. Okay, so two unknowns are there and I have the two equations. That means by solving these two equations I can solve this numerical. So let us write the let us substitute the data into these equations. So first, considering equation 1, considering equation 1, that is y is, what is y? Y is 4 meter, so it is 4 meter, and x is, see, x is from here to here, so it is 5 tan alpha as it is. Then next is g is, what is g? G is 9.81 x square, that is 5 square upon 2 as it is, u square also as it is 1 plus tan square alpha. So if I simplify this one, it becomes 4 is equal to 5 tan alpha minus, so on calculating in the calculator we get this as 122.625 upon u square 1 plus tan square alpha. Call this as equation number 3. So now further simplification is quite difficult, so let us use the equation 2, that is considering equation 2, that is r is given here, r is 9 is equal to u square is unknown as it is, and sine 2 alpha also as it is, g is given here. So this can be written as u square is equal to, see here, it will be easy if I write this equation in terms of u square. Okay, if you want to convert this equation in terms of alpha, then we will get a complex equation. Okay, so the solution of that becomes difficult. So that's why what I am doing is I am converting this given equation in terms of u square. So now that can be written as 9 multiplied with 9.81 divided by sine 2 alpha. So this can be written as 9 multiplied with 9.81, so it becomes 88.29 upon sine 2 alpha. Call this as equation number 4. Now what we have to do is we have to solve this in these two we have to substitute the value of u square in the equation number 3. Okay, so this is our equation number 3. Let us substitute this value. It becomes, from equation 4, equation 3 becomes 4 is equal to 5 tan alpha as it is minus 122.625 upon u square is 88.29 upon sine 2 alpha multiply with 1 plus tan square alpha. So on simplification it becomes 4 is equal to 5 tan alpha minus 122.625 multiply with sine 2 alpha upon 88.29. Now this 1 plus tan square alpha can be written as 1 plus tan square alpha can be written as secant square alpha, because this is the formula for 1 plus tan square. So it becomes 4 is equal to 5 tan alpha minus 122.625 upon this one. So it is 1.389, and this sine 2 alpha can be written as 2 sine alpha multiply with cos alpha, and this can be written as cos square alpha. So here if I simplify this one, it becomes cos alpha cancels here. So here the quantities remaining are 5 tan alpha minus 1.389 multiply with 2, so it is 2.778 sin alpha upon cos alpha. So here it becomes 4 is equal to 5 tan alpha minus 2.778 tan alpha, because sin theta by cos theta is tan theta, and it is 4 is equal to 2.222 tan alpha. So this implies tan alpha is equal to 4 upon 2.222 and alpha is equal to 60.95 degree. Okay, it is alpha is equal to 60.95 degree. So now what I have to do? I have to substitute this in the equation number 4. So that is here. Equation number 4. I have to substitute the value of this in the equation number 4. Equation number 4 is here. So now it becomes u square is equal to 9 multiply with 9.81 upon sin 2 multiply with alpha is 60.95. So it becomes, on solving the calculator, we get it as 9 multiplied with 9.81 upon sin 2 multiplied with 60.95. We get it as 10.19 meter per second. This is the value of u, not u square. So this is the complete solution of the numerical. The only thing is we should remember the formulas of all the quantities, like equation of range, formula for the maximum height, formula for the time of flight, and the equation of trajectory. Then it will be very easy to solve the numericals. Thank you.